Deep under the frozen top of our planet sits a mountain range so huge, so ancient, and so powerful that it is quietly changing everything we know about Earth. The Lomonosov Ridge, a hidden 1,800-kilometer chain of continental crust buried under the Arctic Ocean, should not be where it is. But it could hold the answers to our climate's future, our oceans, and even world peace. For decades, it has been locked away under permanent ice. Now the Arctic is melting faster than ever before, and this underwater giant is coming out of hiding, carrying secrets that scientists are only starting to understand. Nations are suddenly spending huge amounts of money to map it, claim it, and figure out what it means. With every new discovery, the questions keep piling up. How did this lost piece of a continent end up under frozen water? What stories are hiding in the layers that cover it? Why has this unknown underwater feature become the center of so much worldwide attention? Today we are diving into the Lomonosov Ridge, a sunken continent-sized structure that could change both Earth's past and humanity's future in the Arctic. Do not forget to hit that subscribe button and like this video. It is the best way to support this channel. The Lomonosov Ridge stretches under the Arctic Ocean from Siberia's underwater edge through the middle of the polar region toward Greenland and Canada's Ellesmere Island, forming an underwater wall that cuts the Arctic in half. Almost 1,800 kilometers long and up to 200 kilometers wide, it rises as high as 3,700 meters from the seafloor. With parts of its top sitting just 954 meters below the water, it is surprisingly close to the surface for something hidden under year-round ice. Its steep cliffs plunge thousands of meters on either side, creating an impressive underwater mountain range that divides the Arctic Ocean into the Eurasian and Amerasian basins, controlling deep water flow, dirt movement, and even how ice behaves on top. What makes the Lomonosov Ridge even more amazing is what it is built from. Unlike the volcanic ridges that cover most ocean bottoms, this structure is made of continental crust, an old piece of continent stuck in the middle of the ocean. It began roughly 55 million years ago when the European and North American tectonic plates broke apart and a strip of land was torn off and floated away. That floating piece became the ridge. It is a feature so remote that nobody found it until 1948, when Soviet scientists on the North Pole 1 floating station first spotted it using equipment to detect earthquakes. Where it originally came from is still debated, with some theories linking it to Siberia and others to Greenland. Studies using sound waves show complex layers shaped by cracking and uplift during the opening of the Arctic Ocean. Today, the ridge stands as a rare survivor, a trapped piece of an ancient continent whose sediment layers protect an important record of Earth's polar changes. When scientists started drilling into the sediment draped over the Lomonosov Ridge, a hidden world appeared under the ice. Sediment samples taken from the ridge hold an amazing record of Earth's climate past. In some spots, this sediment reaches almost 5 kilometers thick, preserving millions of years of plant and animal material and records of environmental change. Some layers show times when the Arctic Ocean was warm enough to be ice-free in summer, teeming with tiny marine life and fish. These old warm periods mirror the dramatic changes happening today, giving us a worrying look at how past natural changes compare to the rapid human-caused warming happening now. Sound imaging has revealed buried cracks, broken zones, and unexpected layers. In several areas, scientists have found the remains of huge underwater mudslides, probably triggered by ancient earthquakes or by weakness along the ridge's steep sides. These old disruptions hint at an earthquake history we barely know about, and they raise questions about whether similar events could happen again as today's climate and ocean conditions change. Researchers have found gas escape paths, methane chimneys, and buried channels in these deep dirt layers, signs that oil and gas are moving far below. This matters because the wider Arctic region is believed to have a huge amount of oil and natural gas, much of it under thick dirt blankets like those covering the ridge. Just as interesting are unusual heat patterns under the ridge. Even small temperature changes here can affect ice behavior and ecosystems. What lies beneath the Lomonosov Ridge is not just junk, but a deep record of past climates, earth-shaking events, and ocean shifts. It is a history that mirrors with disturbing clarity how fast the Arctic is changing now. One of the biggest discoveries in recent decades is that the Lomonosov Ridge is not just sitting there doing nothing, but actually shapes the Arctic climate. And because of that, weather patterns across the northern half of the world. Acting like an underwater dam, it blocks and redirects the sinking of cold, heavy water beneath the polar ice, a process that is central to the Atlantic meridional overturning circulation, the deep ocean conveyor belt that helps control temperatures from Europe to North America. By controlling how cold water sinks and spreads, the ridge helps keep the Arctic climate stable. It also holds thick, old sea ice in place, as large ice sheets get stuck against its high underwater landscape and become denser over time. This thick ice reflects sunlight and cools the region, but satellites have recorded rapid thinning right above the ridge. As this ice weakens, its cooling effect diminishes, and darker ocean water absorbs more heat. The ridge also shapes how the Beaufort Gyre behaves, a massive swirl of fresh water in the Arctic. This fresh water acts like a cap that stops deeper, warmer water from mixing with the surface. If the gyre becomes unstable because of changing winds, warming water, or shifting ice patterns, it could dump that fresh water into the North Atlantic. Such a sudden flood could upset the delicate balance of the Gulf Stream and change weather patterns across Europe. The Lomonosov Ridge helps set the gyre's edges and flow, making it crucial to keeping things stable. In this way, the Lomonosov Ridge works like a climate keystone, controlling ice formation, water circulation, and the spread of heat. As warming speeds up and ice keeps shrinking, its ability to keep the Arctic stable might weaken, with far-reaching effects on worldwide climate systems. While the Lomonosov Ridge plays a hidden but vital role in controlling Earth's climate, it has also become one of the most fought-over stretches of ocean floor on the planet. Under the Arctic site massive reserves of oil, natural gas, and important minerals. Scientific surveys suggest the region might hold 13% of the world's undiscovered oil and nearly 30% of the world's undiscovered natural gas, a huge prize for countries looking for resources and power in a rapidly warming world. Under the United Nations Convention on the Law of the Sea, countries can extend their territory if they can prove that an underwater feature like the Lomonosov Ridge is connected to their continental shelf. Doing this lets a nation legally turn what would otherwise be international ocean floor into its own extended territory, giving it exclusive rights to explore and extract resources there. Russia, Canada, and Denmark have all claimed the ridge as an extension of their land. In 2007, Russia famously sent a submarine to plant a titanium flag under the North Pole, symbolically staking its claim. Since then, Russia has expanded military bases across the Arctic, sent out nuclear-powered icebreakers, and increased patrols along new shipping routes. Canada and Denmark have responded with mapping missions and legal filings of their own. As sea ice pulls back and new navigation routes open, the competition for control gets fiercer. Sitting near future shipping lanes, the Lomonosov Ridge has become a strategic prize. The tensions around it show not just a race for resources, but a bigger fight for power in a rapidly changing Arctic. With money-making opportunities, military positioning, and legal uncertainty all coming together, the ridge has become a geopolitical powder keg that could shape the next era of Arctic power. Despite how important it is, the Lomonosov Ridge remains one of the hardest places on Earth to study. Year-round sea ice, brutal cold, and months of darkness make direct observation nearly impossible. With no earthquake detectors, GPS stations, or permanent sensors, and with satellites struggling to pick up subtle signals through the ice, the central Arctic remains a huge blind spot. Yet researchers keep pushing deeper into its mysteries. Icebreaker ships carve temporary paths for ocean floor mapping with sound. Robot submarines gather pictures and samples. Deep-sea drilling pulls up dirt cores that show Earth's polar history. Sound studies from floating ice platforms reveal hidden structures within the ridge, while new methods might soon allow real-time watching. International teamwork is growing as Russia, Canada, Denmark, Sweden, and Greenland launch joint trips to better understand this underwater giant. As warming speeds up and Arctic ice disappears, the ridge is shifting from an unreachable frontier to a global hotspot. Its shape influences ocean flow, its weakening ice grip speeds up polar melting, and its position under emerging shipping routes will shape future business and military strategy. Scientists now see the Lomonosov Ridge as central to predicting Arctic change and to understanding the planet's future. This hidden underwater giant, buried for millions of years beneath ice and ocean, is finally revealing itself. And what it tells us about our climate, our resources, and our competing nations could determine the course of the 21st century. The race to claim it isn't just about drawing lines on a map. It's about controlling one of the last frontiers on Earth, a place where ancient geology meets modern geopolitics, where climate science meets national security, and where the future of our warming planet will be written in the sediments of a ridge that time forgot.